Well, first, thank you for Marco and Paul for hosting us again. And so today, my talk is how much does it cost? It's about features. All the time we have people proposing.
Do you need to use the microphone for the recording?
No, it's heavy. Okay. So, here we go. Find a place to stay. Okay. So, every time we are getting new proposals for the language, new features, this is just a small list of some proposals we got this year. And most of the time people propose features, they consider only the advantage, what is good, oh, you can do that, but they hardly consider the costs. What are the hidden costs or the explicit costs of each feature? So that's what I'm going to talk about today. So this is some, I think all of them went to the Lua list. We had a proposal for alternative way to do print format, like in C++, that instead of printf, we have a lot of different operators and a lot of concatenations and things like that. And it seems there are people that like that, so they should bring that to Lua too. There was the UTF-8 aware scanner, a new syntax for methods, a new pattern %b that is like the %small lowercase b, but this one matches without getting the quotes. There is some stuff about toString, use about other meta methods. There was that one that you could create tables with the square brackets instead of curly brackets. It has exactly the same syntax, but assuming to hint the user that you are creating an array instead of a table. There are the proposal all the time. People propose a new array type, so we don't have the confusion between tables and arrays. And all the time we're getting these kind of proposals. Here is just a small example of what we can do with some of those proposals. So here is a UTF-8 aware scanner. So we have this very simple Lua program that it actually runs if you implement the UTF-8 aware scanner. It's, well, I think it's very obvious. Because we have a function that's called function, and it has a parameter function. And if the parameter function is 0, then it returns 1, otherwise it returns the parameter function times the function more than the function minus 1. And with a good editor, probably you could see the difference between those functions, although they are designed to look the same. But for instance, this here is a O, and this one is a omega. What do you mean? Omega? Yeah, it's a small omega. Omicron, sorry, yes. Yeah, it's a small omicron. And there is something different in the other one that I forgot. And here you just have a different kind of comma, so this is the name of the print. And this is a regular comma, and I'm just assigning something to another, so there's a multiple assignment. I'm assigning to this comma, and to this comma, this one gets print, this other one gets nil, and I use that comma here to call the function. So you see that it's very useful, some features. I don't know how we can live without them, but we have to consider exactly the hidden costs. For instance, this feature, one of the arguments for this feature, and actually the argument for most features, is lines of code. So that feature is trivial to implement. it has no lines of code at all, because Lua already has its own internal table of types of characters, like the C-type .h library from C. We already put that inside Lua because we don't like to depend on the locale and that kind of stuff in C. So we already have our own table of what a character is. So we only have to change a few bits in that table to say that anything that is a continuation byte in UTF-8 should be considered a valid character in identifier. So in terms of lines of code, for instance, that proposal of UTF-8 aware, or not exactly aware, but UTF-8 accepting scanner would have a zero cost if you consider only lines of code. And lines of code, of course, is quite relevant. It is a very relevant cost. It's something that needs a lot of lines of code to implement. Is of course expensive, but there are several other measures that we should consider before adding a feature to a language or even to any software. So, one, of course, a very important feature is performance. So some stuff that people propose helps performance because, for instance, you are proposing a new function that does some specific task, and because you can implement that function in C and use all kinds of optimizations, when you pre-implement that function, then you can do that stuff more efficiently, calling that function, specific function, than if you write that in Lua, or even if you write that in C without all the knowledge to optimize the function as it was optimized by the library writer. Of course, features, mainly not new functions, but features inside the language, they, on the other hand, they can have an impact on other parts of the language, and then they can be bad for the language. For instance, I will talk about a good example of that is multiple returns, that even functions that do not use multiple returns have to pay a small price because Lua is dynamic, so every function call can be returning multiple functions. The interpreter must waste some small time, sometimes just one if, but it's always something that wastes time for checking that. And also performance, something that is very strange, but people sometimes forget about that. Some very specific features create huge variations in performance. For instance, that is this great new function that does whatever it is. For instance, some very specific kind of pattern matching, that there is this new function. So if I can fit my problem inside this new function, then I have a huge performance gain. But if I change a little my problem and then it doesn't fit exactly in that jacket that is this new function, then my program runs 10 times slower or 3 times slower. And so this is also very bad for the language, that small variations in your program create huge variations in performance. So usually when we add features, we should consider whether we can implement it efficiently for all cases or for most cases, or whether it could create that kind of performance gaps, performance differences that are very bad for programmers. Another thing that people usually do not consider is the cost of documentation. So a good thing to think about the new features, whether it is easy to explain to other people, and something that is a little different, whether it's easy or hard to understand. Sometimes it's very easy for you to explain, but people do not understand even them. And whether it's hard to guess. I mean, if the feature is more or less obvious, it has some kind of regularity with the language or with other languages, stuff like that. Another point that this sounds like a buzzword, but it's really important, is conceptual integrity. So whether the new feature you are proposing integrates well with other features, it works similar to, for instance, if there are other similar features, it has the same kind of parameters, the same style of use, and where you can use that together with other features, it matches, so you can build more powerful things using them together. And whether it follows general principles, so instead of we have this very specific thing that is, for instance, general principles. A good example is functions in Lua. That is like closures. That's like lambda calculus. That is very old concept, very general principle. Or tables that are just associative arrays. Again, something that is very general. And pattern matching is not general at all, so just not only in Lua, but in almost all languages, unlike real regular languages that came from a good theory, a good base of regular languages and automata. Most languages now with pattern matching is just a bunch of tricks glued together. So sometimes exactly, oh, I want to do that, and you have a specific pattern to do exactly what you want, and I want to do something a little different, and that's completely impossible to do, and you do some kind of hack or you replicate stuff. So another interesting point is exactly, I already talked a little about that, generality, exactly whether it solves all problems of a class or whether it's too specific for one particular problem. Another point that people forget is about testing. Of course, test is very important, but more often than not, people think about testing when they have to test. It's not common for people to think about testing before they implement anything, and not only to think that, oh, I have to test that, but to think, will I be able to test that? How easy it will be to test that? Some features, you see, garbage collection is an example. It's a piece of Lua that's full of examples that things are really hard to test. Sometimes, oh, that's not difficult to implement. Yes, it's not difficult to implement, but it's very, very hard to know whether it is really correct. And also, whether bugs can be severe. Again, garbage collection will be a great example. And that also something that people usually do not think about, or even when they think about it, it's very, very hard to do. It's because you have to anticipate what kind of things you want in your language, and it's usually we do not do that very well. Sometimes after 1 year or even after some months, you have a brilliant idea. Oh, that is a feature that I want in the language, and then you realize, oh, I cannot put that feature in the language because that other feature conflicts with that. Again, you see that, and not only in the design space, not only whether I can add features, but also whether I can change the implementation. I can implement Lua in different platforms, etc. And sometimes some features are very easy to implement in some specific architecture, and then when you change architecture, you realize that that feature is a mess to implement, but then you implement without that feature, so you have kind of different kinds of Lua, different kinds of platforms, and it is really hard to anticipate that. So now we are going to see some case studies, so some features that we did implement in Lua. Those are not features that we could have implemented, but exactly features that we did implement, so we have insight to measure the cost along the time, for instance, that cost against evolution, that kind of cost that only with time you can see. This is a very, very, very old example of a problem we had with solving with incompatibility. But in the first version of Lua, we used a single equal sign both for comparisons and for assignments. And so that's very smart. We can do what that kind of stuff. Oh, we can do that. So why not do that? It's easy to implement. It was easy to implement because the syntax of Lua at that time was very restricted. So it's very, oh, that's great. Why we use two equal signs? We can use one equal sign. At that time, a lot of other languages used a single equal sign for comparisons. Because as I said, the syntax of Lua at that time allowed that kind of distinction. So this is the kind of thing that I say, oh, we can do that. But of course, maybe it's not a good idea, but it's so, it's so smart, and I can, even to show that you are smart, I can do that. No, it's that trick with the syntax. And then a small change, because in Lua 1 we use a different syntax for records and for sequences. And then when you unify the constructors in Lua 2, then the equal sign could be an assignment or a comparison, and we had an ambiguity, and the solution was, okay, we are going to use two equal signs for Lua. But at that time, from 1 to 2 was easy to change that. After you have more users and more programs within Lua, that kind of change becomes more and more difficult. But this is an example that we did not anticipate. We said, oh, we can do that, it's smart, okay, let's do that. And then just exactly the next version, like 6 months later, we said, oh, we can change the syntax. It's much better to have a unified syntax for all constructors, but oh, there is a small problem with the equal sign. Another small, we like that actually, but it's something that precludes something that we don't want to do. So in that sense, it's a good thing that comments in Lua, the double hyphen, you have that in Haskell, you have that in AFL, so there's several other languages that use that, but we cannot have a decrement operator like in C. And because of integrity, it's not very nice to have an incremental operator. It's strange, we have plus plus, but we don't have minus minus, which precludes the new language Lua plus plus too. So this is the kind of thing that, at that time we actually, I think we thought about that, but it's a kind of thing that if we didn't, why not to have increment in Lua? Oops, we have a problem with comments. So it seems completely unrelated, and then we realize, no, it does have a cost to have that kind of comments, because exactly it impairs your ability to evolve. And also the comments with, that was also a problem that when we introduced comments with double square brackets, also we had problems that looked like, oh, we can put any kind of code inside that kind of comments. And then later we realized, oh no, it's actually not uncommon to have two closing, double closing square brackets in Lua code. And so we introduced the equal signs as kind of stuff to fix that. Multiple returns is something that is very interesting. It's very powerful. It's something that I really like. It helps a lot to write functions. You don't have in and out parameters. You don't have to put containers to get out parameters. It's really, really useful. And also it allows the generic call mechanism, that is to pass a variable number of parameters to any function. But it does have some problems, some hidden costs. One is this kind of conceptual integrity, because it's multiple returns is a kind of a data structure, not exactly a data structure, but it's a restricted kind of data structure that is second class in the language. For instance, sometimes you can pass those multiple returns as multiple arguments to a function, sometimes you cannot, sometimes you can do other stuff with those parameters, most of the time you cannot. It has a lot of problem with nils, because exactly we always insist that good sequences should not have holes in the sequence, but when you collect the result of functions, Lua libraries themselves use nil forward but something else, so you create bad sequences. I mean, lists there are not sequences. And also multiple returns has some cost in implementations. So in some platforms it would be useful if, for instance, you could translate Lua function to a native function in some other language, but most other languages have simple returns. So the Lua function with multiple returns cannot be translated directly to a function in other language, because it would have to return some kind of data structure, or it would be much more expensive than use the native return mechanism of the platform. And as I already mentioned, we have a small cost, very small, but it does have a cost even when we do not use that. Every single call we have to do one very quick check, but it is a check to see whether the function is returning more than one result or returning no results, and we have to adjust the number of results. Most of the time we want one result and the function is returning one result, or we want no result and the function is returning 0 or 1 result, but we have to check for all cases because they can happen that we do not know. Varargs, the new style of Varargs, the 3-dot expression, is again something that has a very, not a huge cost, but a good cost in conceptual integrity. Again, this is a even worse case of a second-class data structure mechanism. A lot of times people are proposing in the list how to use varargs to do strange kind of things. For instance, some time ago someone proposed to create coroutines so they can have their own varargs to store stuff. Of course, not very efficient, but it's, again, it's clever and you can do some strange things with that. And also, again, with conceptual integrity, when you put varargs, the main reason of varargs is to avoid creating a table when you call a vararg function. But table is the main data structure in Lua. Almost everything you do in Lua, you create tables. So when you demonize, when the language itself kind of tells, oh, we are trying to avoid create tables, you kind of demonize the idea. People already start to think, oh, I should avoid create tables too, even if it's not a problem. I don't have any performance problem. But that's what I thought conceptual integrity, how you think about the language. You already think you have this mental attitude that create tables is not a good thing. It's something that I should avoid all the time. So that's not a very good message for a language that uses tables for almost everything. And again, like multiple returns, varargs has a small cost even when not used, because the way it is implemented. we have a small, the framework we had for that. It's used for all Lua functions. They have something that tells whether it does have varargs and where are the varargs. And when it's empty, it's okay, but you are wasting some space in all call frames to tell whether the varargs are there or not. The incremental garbage collector, I already mentioned garbage collection. This is something that is really interesting in terms of costs. For instance, in terms of documentation, it's almost no cost. I mean, for the user, this is almost invisible. But it has, implementation is it's hard, but it's not that hard. The real nightmare if an incremental garbage collector is testing. It's really, really hard to test. And for those that don't know, what is an incremental garbage collector? Is a garbage collector that collects garbage not exactly concurrently, but sharing time with the application. So the application runs a little, and then it calls the garbage collector that does some little work, and the application runs a little, and the garbage collector runs a little more. So you are collecting garbage at the same time that the application is changing the data structure. So while we are collecting garbage, new stuff are becoming garbage, and so it's really, really, really difficult to test, exactly because of this, the iterations between, I mean, anything that is concurrent. I know people know that it's really hard to debug, so this is not exactly concurrency, it's not real concurrency, but because the garbage collector is driven by how much memory you use, even small amounts of memory, of differences in memory you are using, changes the time the collector is being called, and so changes this interaction. For instance, if you change the name of the application, I had this experience more than once. You have a program called Lua, and you decide, oh, I do a similar one, but it's called Lua 1. And then, but because it's called Lua 1, when it put that enters in the arguments to the program, so it's a string with 1 extra byte, and that extra byte is enough to change the allocation. So Lua 1 runs the allocator in a completely different way than Lua, because it already starts with a small difference in how much memory it is using, and that 1 byte, oh, that one allocates, that is doing exactly the same, but this 1 byte is enough to trigger the first allocation first in that program, then in the other one, and from there everything is completely different. So it's really hard to test, because anything you change, you cannot reproduce the bug. And bugs are very severe. I mean, the typical kind of bug you have is you have just either you have dangling pointers, or you have shared pointers. I mean, what's the problem? Yeah, but okay. So you have things that are being deallocated and are still being used. Both kind of bugs are hard to find, hard to debug for themselves. So since you use a regular debug, all you see is, oh, okay, I'm using a block of memory that was deallocated like a long time ago, and who deallocated that? Of course, the garbage collector. That's the only piece of code that ever deallocates something, so the debugger gives you no hint at all about what's really happening. And why it was deallocated? It was deallocated because the garbage collector thought it was not being used. And again, because it collects what it's not being used, it doesn't have a reason to collect garbage. The problem is that it didn't see a reason not to collect the garbage. And so it's really hard to find that kind of bug. Why it didn't see a reason to keep that pointer alive, it's really hard. That kind of bug is kind of, when we see that this is a bug in garbage collector, it's kind of, well, that's going to be hard to find. Finalizers and weak tables are the kind of at the points where the garbage collector becomes visible to the program, to the programmer, and they are key ingredients. In particular, because of the Lua C API, this kind of stuff are even more important in Lua than in other languages, because a lot of times you have to deallocate stuff in C, and so you need that kind of ingredients. Sometimes you have C code that references Lua, C objects that reference Lua objects, and the Lua object reference back the C object, and you have this kind of cycle, so you need weak references or in the form of weak tables to break those loops. But again, what's the hidden cost here is that a very big impact on alternative implementations. For instance, if you want to implement Lua in a language that does have garbage collection, and you want to use the native garbage collector, it's really, sometimes it's really hard to implement the Lua finalizers and weak tables with the guarantees, with the semantics that people expect from weak tables and finalizers, with a different, completely different kind of garbage collector. And of course, it does have some costs in the garbage collector itself. That's not very problematic, but the garbage collector is not a big cost, but it is some cost. The garbage collector has some restrictions in implementation and some extra housekeeping that it has to do when you use finalizers. Well, the length operator, I think it's a very good example of a big problem in documentation. It's very easy to explain. I mean, the explanation is one paragraph, and if people really understood the paragraph, they would understand the operator, but people already have a lot of expectations of what that operator should do, and so it's really difficult to understand. Even if the paragraph, the explanation is clear, it's not what people expect, so it is clear, but people just don't read or read and say, oh, I probably did not understand correctly. Probably it does what I want it to do. And so this is it. And it has, as I already said, it has some conceptual integrity because it fights both without args and multiple returns, in particular with multiple returns because of the problem of the mills. As I said, when you collect multiple returns and you have mills there, then you create the kind of stuff that you should not use the length operator, so they do not interact very, very well. String methods, this is something that we introduced in 5.1, 5.2, kind of recently, and that is a good example of something that, why not? It's very easy to do. All you have to do is to put the string table, the string library as the index in the meta table of strings. So all operations that you cannot find in the string, you look in the string library and everything works perfectly. Actually, all the examples are wrong. It should be a double, should be a column. And it's easy to test, it's easy to document, it's easy to explain, and the information application is easy, but it has a very big problem of conceptual integrity because it becomes the only way that we can call functions in Lua without having access to the functions. So this just breaks all kinds of sandboxing, old style sandboxing in Lua. Because in Lua, before that, to call a function, you need to have the function, the name of the function accessible to you directly in the environment. If you remove the function, then you cannot access that function anymore. And this is a kind of a backdoor, because you can always access the string library as long as you have access to a string. And you just put click, click, you create a string, and once you have the string, you have the whole string library available to you. So this is a process that I particularly regret that. Even I use that stuff, but I would prefer not to have that because of this problem. It's really something that, oh, it's nice, it's good, it's simpler to write, but it has this kind of concept onto the whole idea of rule of environments, and everything is a function, and you have access to functions with functions, or you have access to things of an object only if you have the object. For instance, the same thing happens with files, but you can only do file operations if you have the file handle. You cannot create a file handle out of thin air, and you can create a string out of nothing. You just put bricks in the string. So this is not great. And coroutines, this I think is the big example of something that really affects the whole implementation and the whole language. I think it's the biggest single feature that affects everything. And so first, it does have a small cost even when not used. I mean, for any kind of implementation, you have, even in assembly, you always have to be prepared. You have to know whether I can put stuff in that place, whether that place is safe to preserve data if a coroutine interrupts me. So, and the problem exactly is, the good thing about coroutines in Lua is that they are both stacked, and you can yield a whole bunch of calls, but that means that functions in the middle of those calls can get interrupted without knowing that they are going to be interrupted, because they call the function that use, so the function itself doesn't know whether something is calling will yield or not, so you have to be prepared to yield all the time. As I said, implementation that means spread over the whole interpreter, almost everything we do. We have to keep in mind that this stuff can be interrupted by a coroutine. There are some very nasty interaction between the garbage collection, closures, and coroutines. There are some very strange kinds of cycles. So you can have a dead coroutine that created a closure, but the closure is alive because it was passed to some other coroutine. So people are calling that closure, and the closure are using variables that are still in the stack of the dead, so that the coroutine is not dead, but I mean, nobody can activate the coroutine again. But before you can collect that coroutine, you have to close all closures that use the variables in that stack, and that can create cycles, because you can have that one of those variables can be a closure that refers to another coroutine, etc. And again, it's a nightmare to collect that, and it is a nightmare to test that, to create exactly that situation. Oh, I have to create that, and then you test, and oh, everything works, and then 2 weeks later you realize I'm not testing anything because there is this variable that I forgot to erase, and so this variable is keeping everything alive, so I'm not testing what I should be testing. It's that kind of reverse test. You put some small bug in the implementation, now it has to crash, it doesn't crash, and so what test I have to do so that that proves that I need this extra if in the code. It's really hard. It's hard for cheats, it's hard for, as I said, for any kind of alternative implementation. And as I say, it's hard to test not only in the garbage collection, but it's hard to test in general because all again, it's more or less like concurrency because it's something that can occur in a lot of places and you have to test, oh, I have this function, a yield can occur here, 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 and here, and whether I can recover all those yields and whether I really save stuff in the proper places so I can recover them all the time with all kinds. For instance, now that we can interrupt opcodes, and then some opcodes, when they are interrupted, the opcode itself has to finish its execution, and to do a proper testing, you should test that all opcodes are being interrupted and then resume to check whether they are working properly. So it's difficult to test. And integers is the same. This is actually an advertisement because it has some nice stuff too. Integers, some costs are very obvious. I mean, it's a lot of lines of code too, because a lot of places when you just have to manage dumb floats, now you have to check. This integer, you do something, whether it's float, you do something else. You have some small price. When not used, actually you have to pay the price when you do not, now you pay the price when you do not use integers, because most operations we expect that integers are more common than floats. So for instance, most arithmetic operators, they first test whether they are operating on integers, and if not integers, then they check whether they are floats. So operations with floats become a little slower. But we have some gains when using it. Of course, integer operations are faster in several architectures. When in small machines, integer operations will be much faster than float operators. We avoid conversions from float to int. That, for instance, occurs all the time when you index an array. And these operations in some, the Pentium was very bad with this conversion. Now most machines are not that slow, but anyway, it's some small gains that we have using integers. And we did have a big gain in conceptual integrity of the language. This was one of the arguments to introduce integers in the language, because a lot of places in Lua already had integers, but they were not explicit. For instance, parameters to the string library, array indices. 2 months ago, someone came with some bugs in indexing arrays with really large integers, because it's because the code is still inherited from the old implementation. And exactly was kind of very big integers. It's kind of fuzzy. It was kind of something that was not very explicit. What was the limit of integers? What happened when you had to convert floats to integers? Sometimes the conversions were different when you index a table, when you use a string library, when you use some other library. So this is where the problem is that you define the limits and you define the conversions. And now with integers in the language, everything is much clearer. You have an explicit rule how to convert stuff to integers. You have an explicit rule of what is the limits of integers, how they behave in those limits. And so the language is much more clear in that part. It's a lot of corner cases just disappear. So this is the what I had to say. A lot of applications. This is curves in programming languages that, I mean, not only programming languages, but also any kind of software. This is the bloating rule that you can always get a lot of benefits from small additions to the language. And so that's why people propose different stuff. But most of the time people need very small additions, but different small additions, and a lot of people need those. And if you add up all those small additions, you come up with a huge language. As I said, it's very hard to foresee the consequences of a new feature. Sometimes you think, oh, this is just easy, it just has no cost, and then, as I said, 6 months later you consider, well, we should have plus plus and minus minus in the language, and then, oh, but my comment is already minus minus, so I can add that to the language. And of course, to avoid bloating the language, features should be measured not by themselves, but against competing features. Or that, oh, this feature is very good. Yes, it is, but there are 1,000 other features that are as good as this one. All of them deserve to enter the language, but if I add those 1,000 features into the language, then you have a very different language, not the kind of language that we want to have. And the final remark is that we can earn both adding a bad feature or blocking a good feature, and one of these errors is much easier to fix than the other. So that's right. Okay, thank you. Questions?
We all know that breaking changes are bad. Do you think there's a way to make them not hurt as much if you need to add a breaking change to the language?
Say again? A way to make them not that bad?
Yes.
Well, no. What we do have, I actually, once I gave I don't remember a whole talk or a piece of a part of a talk about that. It's again how to measure, I mean how to anticipate the impact of a change. So we have stuff that we consider light changes, medium changes, bad changes, and unacceptable changes. It's a whole scale. So for instance, a good example of a really bad change would be indexing arrays from 1 to 0. You have no syntax errors, everything looks like it's working, but it's all code becomes, just the logic of all code becomes broken. It's a nightmare to fix. A syntax difference, for instance, suppose we are going to eliminate an operator. It's hard, it's bad, but at least you get a syntax error up front. So it's, if you have an alternative, it shouldn't be that difficult to change. You just put, okay, you change that operator for a function call. It's bad, but it's much better than some, or sometimes this is a feature that nobody uses. Sometimes we change and really nobody uses, and people do not even notice that we remove the feature. So, of course, sometimes it's difficult to anticipate. There are there's also some vocal people, for instance, where we remove the
math library functions?
Yeah, the math, what the name of those functions? The
Hyperbolic?
Hyperbolic functions, yeah. For instance, that was the Dirk, he worked with hyperbolic. I think his thesis was about hyperbolic functions. So for him it was really something. I think it's the most important part of any programming language, hyperbolic. And I believe that people that know what are hyperbolic functions can do lovely things with hyperbolic functions. But most people don't use that exactly. So it shouldn't blow the language for something that poor guy that really. And so there is this kind of stuff. We did, for instance, for the hyperbolic, for the math functions, we did a search in GitHub and in Lua Workshop. At that time was not that populated, but I think we went through Lua Workshop too. We went through a lot of code, and the only place we could find the hyperbolic functions being used was actually, that's also funny that because people replicate code all the time, so we found like maybe 30 instances of the same code that people just copy. And that code was just saving the math library in some other table, and so it went through all the math functions, and so it saved the hyperbolic functions, so we didn't call the hyperbolic function. But the only mention of hyperbolic functions in like a few million lines of Lua code. So we try to anticipate that kind of stuff. Of course, functions are much easier to remove because then sometimes you can just provide an alternative library or even implement them in pure Lua. So we have a kind of scale to it. But hard changes are hard. The only solution is to change the big numbers, as this is Lua 6 and good luck.
If you didn't care about backwards compatibility, are there any features you would take out from Lua?
Pardon?
If you didn't care about backwards compatibility, are there features you would take out of Lua? Would you maybe remove var args or take out integer support or things that you regret adding to the language?
O que você tiraria se você não se incomodasse?
Oh, what I would remove?
Oh, you said one of them was the meta table for strings.
Yes. Yes.
Anything else?
No, it's difficult to say them alone. The first thing is my filter gets, oops, I was going to say.
If anyone noticed that var args have changed a little.
Oh yes, yes. var args, for instance, I did change var args again, but that will be fully compatible, but it will be slow. People will not notice it. We point out that it is var arg. We went back to the old implementation that creates a table, except that now the 3 dots is an expression that unpacks the table. So
You metric codes for art.
The implementation is almost the same. It's just a little optimized, but it's almost the same as it was before the new var args. Everyone else is hard. Well, there is one big, not something I would remove, but something I would change that I think would be a good change. But again, that's the kind, it's a kind of thing that it's difficult to anticipate the impact of the compatibility, is to allow nils to be values in tables. Absent key is not the same thing as key with a nil. We should have like 2 operators, delete key and check whether a key exists without an absent key would return nil, but there is a difference between a key that is present with a nil value and a key that is absent, that would automatically solve the problem of the length operator. I think it would solve a lot of problems, but it's really hard to anticipate. I think most people would have problems, but a few people would have some very strange bugs. They expect, for instance, when you remove something, just assigning nil to the last element, and then you expect the length to be one less than it was, not this one. But this is something that I really think that would solve that whole problem. Because people, we always think about that arrays cannot have holes. And the problem is exactly, it's not that arrays cannot, the problem is that tables cannot have holes. But in tables you don't care. And in arrays we do. The real problem is that once tables could have nils, then arrays could have nils. So the problem is not that arrays are tables. The problem is that tables miss a feature that when you use them as tables, that feature is not important or not that important. And when we move to an array, then that feature becomes important. And sometimes even multiple returns is something that you, I mean, I would not remove, but it's a much larger cost than we anticipated. So all the time, well, we want to implement Lua and whatever, and this is always a small thing, or even to do a compiler for something else. It's always it's unbelievable how.
Is there something that you wish you could add to the language, but you cannot anymore because of the previous decisions?
It's also difficult. Well, in one sense, what I said about nils in tables is that I would like to have a function, I would like to have that semantics, and I cannot have that because I have the other one. It's not exactly one feature versus another, but it's that kind of stuff that I cannot change with that. Not a specific feature. I don't know. It's probably 10 minutes after I finish here. Something will come to my mind. At least there is not something that I'm thinking all the time, oh, I wish that, but I cannot do because of it. Thank you.